Hello everyone, I would like to go over chapter 7, section 7.1 and 7.2. In chapter 7, majority of the information you will learn about perimeter and statistics. We're going to using those in order to figure it out. We call confidence interval. And I would like to open up section 7.1. Right now, as you can see, it's right here. So in this chapter 7, survey sampling and inference. And again, this is kind of the fancy word to describe whatever, to describe the information that I shared with you earlier. 7.1 is about learning about the world through survey. And the objective will be distinguished between populations and sample. So we have learned population and sample in chapter 1 already. So you know kind of how population look like and how do we call it samples. Perimeters and statistics. A perimeter and statistics is kind of notation or numerical value to describe the population and sample. Perimeter will matching up with population, and statistics will be numerical value matching up with for sample. And we will learn how to identify possible sources of bias in survey. So this topic is not necessary on the test. However, you should know how does it look like and how do we figure it out bias. Identify the features of a simple random sample. They given us like some information to identify. We call simple random sample. Simple random sample is actually, if we understand this concept, it's just like a very small amount or small small groups. We call that simple random sample. Next, to get into the concept with population and perimeters, as you can notice, population and perimeter, they usually pair them up because all the time they have to they go together. It's not separate. The definition for population in chapter 1 is a group of objects or things or people to study, like a very big group, a very huge group that you want to study, you want to do research, you want to do an investigate on to figure it out, the question that you want about that group. And perimeter is a numerical value. Like I said, it would be a number. Perimeter for population is depend on if they're talking about the mean of the population or is talking about the standard deviation of the populations. They call perimeters, okay? But they have different notation. For example, this perimeter about population, if they want to discuss about we call mean. Mean in chapter 1 you learn mean is the average, right? Or mean described in these populations, we call the notation for that would be mu, like this. And of course, for mu, you will have a value, right? All the time, they provide us a value right here, like a value, okay? And sometimes they want to talk about the standard deviation. We call population standard deviations. Population standard deviation. And the notation for this, you will see this as sigma. And this also is a numerical value, is a value right here, okay? It depends on the story, what value that they provide, then you check that out. So those kind of the example, and for population, perimeter of the populations. Next value. Let me see. And here is the example. Populations and perimeters example. So here's look like the application for you to read this and analyze what is the population and what is the perimeters in this case. Data is gathered on the heights of all NBA basketball players. The mean of the data is calculated. So here actually, because it's so general, usually they're going to give us a number, but here they just like say in general, the mean of the data, which is the mean of the height of all NBA basketball player, equal to a number, but it didn't tell us. It's okay. So because it's general, actually in reality, for the actual example, it's not like this. The actual example, you have to know how to figure it out what is the mean of the population and all other data that they provide us. For this case, you don't need to worry about this. This case, you just learn how to figure out populations. In this case, population, they're talking about all the NBA's basketball player, the height of all of them, right? They are populations. It looks like they don't give us the specific value, specific number. But in this story, we just know that they talk all about NBA basketball players. They will have the heights of each. And they take the height of each person to compute the mean or the average. And we call that value will be perimeter. For this case, the perimeter for this case will be mu equal to a number, right? But it's so general, so they don't give it to us. But you understand that we call perimeter. That's notation for perimeter of the mean of the populations. Okay. Next page. Measuring populations. The way that they measuring population, they usually using census, survey, and they're using different kind. But but one of the example we call census, because I do not know if you remember, like for this year, 2020, each household will receive an email or message or a letter telling us to filling out all the people living in the house. So that is the way that they having, we call it having the census. They want to know how many people living in the household, so that when we report back to the to the department of collecting all of this data, they will have the information. That is the way that they're doing survey to know, to know the entire America, having how many people living in America. So right here to say a census is a survey which measures every member of a population. So that is one of the type they measuring to know how many people or how many things, in this case, of the populations. Most populations are too large. Of course, if we count like individual right now, like people got births, they got birth, they got too many babies, they having, and some people die. So they would like to know, like, I think every 4 or 6 years, usually I think 4 years, they will do a survey again, because they would like to know exactly, because those 4 years, some people will dying, some people have newborns baby and stuff like that, marriage, they become a family and so on. So every 4 years they will throughout the census again testing the entire populations. And since America is too large, they having too large number. That's why they sometimes they might only using like just a group of um, a group of the uh, the people um, that who are answering the question that they sent out, because for the census they recommend us to do it, to filling out the paperwork. um, some family like they don't know anything. Since this is like not really not really like a rules, it's like just like your knowledge about like helping the department to figure out how many people live in a house. So um since that case happened, that's why like they're not getting exact value. So they, another word they were using, we call sample. Sample is like they just collecting um, only those who prefer to answer the questions to estimating the entire the United States. It's kind of a bit complicated when you're thinking about this, but I believe that um, for this definition right here, you kind of got a big picture about census. That is the way they are measuring. Okay, so if you have any question, please email me um, to um, to ask. So the next, let me see, the next slide, they talking about samples and statistics. A sample is a collection of objects, people, or things taken from the population of interest. Right here, like I get, like we mentioned earlier, um, the populations of the interest is mean like you like to investigate in that area, that field, then you want to know um, something about that group, big entire group. So in order to do that, in order to measuring it, you don't have to like asking every single one of them, but you can collect out, you can just like decide, I want to investigate, I would like to ask question on this group. Many other measuring about this, I have known that they calling us, they calling your phone number and then telling you like, can you do a survey? Can you do a survey? So that is the way that they are collecting data to study something, to because they interest something. That's why they make that um, um, move to, you know, spend time to calling us, emailing us, texting us, and all kind of things. And for sample, they, like I said, they just collect out, they just like have a small group. I'm sorry. Okay. And statistics is a numerical characteristics of a sample of the data. It's similar to perimeter of the populations. Statistics is kind of a word that um, helping us to when you have a story, you have to know how to figure out this is statistics or this is perimeter. And also statistic all the time will go with sample. And statistics, if you're talking about the mean of the sample, we call that statistics. And notation for statistic talking about the mean is X bar, okay? And statistics talking about the standard deviations, standard deviation, they usually call this as small s. You have learned this in chapter 1, right? It's familiar. And that's why they have a new name. They have a formal name we call statistics. And actually, statistics is a numerical characteristics of a sample of the data, because statistics is used to estimate the value of a population characteristics. It's sometimes called an estimator. So you can call statistic is the estimator. So because X bar estimating mu, right, for mean, and sigma, and small s, estimating sigma for the populations. It's kind of like that. So usually like the entire population is too large. So they will just collect out the sample, like less people, less things to investigate. So they save time. So from there, they can estimating the entire populations. That's how they do it. So let me rate this and move on. Again, if you have any question, please email me. So look like this 7.1 mostly about definitions and how they teach you how to identify sample, statistics, population, and sample, right? And a perimeter, I'm sorry. This following example, so let's read over this. A researcher is interested in studying the heights of Americans women. She takes a random sample of about 1,500 American women, find, finds the mean height of the sample is 63.6 inches. So it looks like the data they given us is, do you see that the value right here? And they say here they take a random sample. So this random sample notation for this will be like n equal to 1,500, right? The sample. We have the mean of a sample is this. It's mean they given us x bar is 63.6, and the sample size is small n. That's the sample size for the sample. The size for the sample is small n, equal to 1,500. If the big N right here is represent for the number of the population, but here usually to estimating the population they're using just the sample size and the sample information. The sample is 1,500 American women, and statistics is the sample mean of 63.6 inches. The researchers may estimate that the average American women is 63.6 inches tall. I would like to check if I'm sharing. I'm recording. Okay, good job. Okay. Statistical inference. Statistical inference is the art and science of drawing conclusion about a population based on observing characteristic of a sample. So here is two things that you need to describing statistical inference. It involves uncertainties because the entire population is not being measured. So this is kind of if you can imagine, no one knows exactly the population of the United States, right? So that even though we're having a value, a number, a very huge number, but that number is uncertainty. Like I'm telling you, like I share with you, some people do not want to report in a census. They shy, or they don't know English, or they just moving illegal, or they living here illegal, so they're not going to report that. So, but in reality, so there is more people living in the United States than the actual value that you see. So that is one of the, we call it involve uncertainty because the entire population is not actually being measured. An important component of statistical inference is measuring out uncertainty. As again, it looks like right here they're talking about uncertainty mostly. So statistical inference is just like helping us to draw out a conclusion about the population based on just observing, based on the collecting only, not the reality. An example, in January 2015, the Pew Research Center published a report stating that 37% of Americans believe that genetically modified food, we call GMOs, were safe to eat. This was based on a survey of 2002 American adults. Identify the population and the sample. This is the question that they asked. Identify population and sample, and then what is the perimeter of the interest and what is statistics in this case. For this one, first you read the story. So now our turn to identify 4 things: population, sample, perimeter, and statistics in this case. So you look at this ones or here. If you understand the definition, population and sample, so right away you were having a value, right? So look like right here. So let's repeat one more time. In 2005, that center reported that we have 37 Americans believe. So this will look like a value right here given to us. And if they given you something like this, I will call this will be statistics. This is a value that's described, that this is the value that described for a sample, right? Usually the entire population, unless they know exactly the value or they uncertain about the value. So that we call populations. And for this case, 37% here, I call this statistics. Now I keep moving on. Of all Americans believe, for those are American that who are believe GMO was safe to eat. So this is, what do you think? Is this a sample or this is the populations? So the population will be the entire of Americans, right? In all of the Americans, we are know that 37 of Americans that believe that GMO was safe to eat. So Americans that believe the GMO was safe to eat, you might call this a sample, and the entire Americans will be populations, okay? And the perimeter in this case would be the percent of the Americans who believe that GMO was safe to eat. A lot of wording, a lot of writing, so I don't want to write it. You can see there will be the solution for you to identify with a lot of writing. I just want to say I would want to say that 37% here we will call the sample that of we call statistics of a sample, or we call this would be the value, right? You can call it X bar, right? The average of the American believe that. And another 63%, you might imply 63% would be the people, the Americans who do not believe GMO was safe to eat. So the people who believe and the people who do not believe, you add them up, they become the entire population, which is we call populations, okay, which is all the Americans. So let's move on to the next slide. So right here is the solutions. The population is all American adults. And the sample was the who was the survey? I'm sorry, I missed that part. Will be the 2002 American adult who were survey, who got the survey will be we call that sample. So in those people who got the survey, about 37% of them answering that they believe that GMO will safe to eat. So that would be called statistics down here. The perimeter of the interest will be the percentage of the American adults who believe that GMO will safe to eat or safe to eat. Okay. And again, if you have questions, please email me. Now we identify between statistics versus perimeters. Statistics are knowable all the time. They give it to us. Perimeter, they don't give it to us. Usually they are unknown, or sometimes they have to give us that fully number, like the real number. If they're talking about just a small group, they present that to be the populations, then that become a perimeters. So here, the example will be, so we have two examples down here. So the first example, in election day exit polls, 81% of those who describe themselves as conservative said that they had voted for Donald Trump. The second example is Winston Churchill painted more than 500 pictures in his lifetime. So we have the keywords as we notice here. The first example, let's analyze that one. So here we are identifying perimeter or statistics. Perimeter will usually matching up with populations, and statistics will go with a sample, right? So right here, they given us a percentage. Look like, okay, they don't have an actual number, an actual value. And here in the post day, 80% of them said that they had voted for Donald Trump. So this will be called statistic. To me, statistic. And the reason is knowable, right? And it's talking about like a group of people who voted for Donald Trump. The second example, they're talking about the artist Winston Churchill. He painted. We don't know. Really know like exactly how many, but we know that for sure it will be more than 500 in his lifetime. The word lifetime is mean this kind of describing the entire population, the entire of his life, entire of his, like in his life, the maximum that he painted would be more than 500. So this value here will be called perimeters. Okay. So here is the solutions. Number 81 is statistic of perimeter. Is statistics because the number 81% describes a sample of the people. Okay. And is the number 500 a statistic of perimeter? Is it a perimeter because it's described a population which is the collection of Churchill's painting in his lifetime. Here we have some notation describing. This is you need to know. So this table is like a summarize. This table is like a summarize. Here's the statistics. Statistics, like I said, it's not only talk about the mean, but it can talk about standard deviation, variance, or sample proportion. You learn this I think in later chapter 7, you will learn this. Sample proportion will be a value. It's like a fraction value. You will learn later how to compute this. And we have perimeters. We have right here this notation for sample perimeters, and we have this notation for statistics, kind of notation for statistics based on each of this, you will write different notation. If you think that they're talking about sample, then they will notate for you this kind of notation. Otherwise, they write the other side. The bias section won't be on your test. However, like I said, it's good to know that that what is it? Okay, so let me pause a minute. Okay, get back to work. Right here, they given us an example about measure bias. So results from asking questions that do not produce a true answers, because it's here the bias is like is happen because some people might lie like the questions, like they answer the question not real. It's just like a fake answer. Like for example, if I'm talking about, like if I'm asking the height or even the weight of someone, so people might shy to talk about their actual weight. um so when that question, like if I'm asking them that question, they might not telling the truth. So that is one of the way that measuring bias. So and just like right here you can see the example. That is quite one of the way that they might avoid answering the question correctly. And we are having the measurement bias can occur, including it might be self-reporting. For example, you might open the Facebook account, you might not given might not write the actual life of yourself on Facebook, right? Not all of you, but maybe some. And some of you might be liar with your age, with your height, even your photo, right? Your actual picture. People may doing a lot of Photoshop with the picture to make the picture prettier. It's kind of the not real. So that's we call self-reporting or personal data, the use of confusing wording in a survey question. For example, you don't really understand the question in wording, and you might guessing and you confusing yourself and answering whatever that you think. And maybe the use of non-neutral language in questions. And again, they guessing it because the language, because based on the wrong language. A sampling bias occur when using a sample that is not representative of a populations. So another example about bias we call internet polls. And even when I'm doing lecture, I'm asking you, I pull out a poll, and I'm asking you if you understand this chapter, this section or not. Maybe some you'll say like, yeah, I understand it. You click yes, only yes or no. And some people might like do not really understand this. You might say, you might also say yes, right? You try to say no because you might be afraid of your friend thinking like they understand but you don't understand, stuff like that. Or maybe like, oh, a math problem that I just give it to you to do it. Some people do not know how to do it, but they try to answer the question. They might say that I understand it, so that I might be not bother you again. Different things like happening. Uh, actually, all kind of this happening, we call statistics. So all the time we're just guessing. Not 100% all the time will be real answers. So we are estimating. even when you do a survey, when we having a poll, something like this is happen. So sampling, important question to ask about sampling. Sampling first, what percentage of people who were asked to participate actually did so? So you know sampling already, right? Sampling, you take out a small group, and you asking the question, you do a survey, and how many people really answer that question. That's we call that the statistic of sampling, of sampling. So second, did researchers choose people to participate in the survey, or did the people themselves choose to participate? They can give us like kind of that question so that they can give us a hint to thinking about we call sampling. Okay. This won't be on the test, but on the test you have to know how to identify sample or population and those kind of the data. So here's look like just the definition for you to support more about sampling, sample, populations, stuff like that. And next, if a large percentage of those chosen to participate refuse to do so, or if people themselves choose to participate, the conclusion of the survey are suspects, right? We suspect. We, like I said, not all the time people telling the truth. Not all people telling the truth. Okay, next example. Identifying sources of possible bias. A school district is interested in finding out what percentage of voters in a district would favor the passage of a school bond measure. The district sends out a survey to all school parents asking, do you favor passing of the school bond measure to provide additional resources to improve education opportunities for your students? So it looks like this question is not applied for all parents, right? So because of language, because many parents is not all of them are native English. So they might second language, they might not understand the way that they're asking is too long, too many wordings, stuff like that. It's make them answering suspectly, right? We would suspect their answers. They might answer, based on their understanding about this. Is it really like uh, right? They not they might think the other way, not exactly as the question asked. So here identify any sources of possible bias in the survey. Like to me, here I think it's about wording. Language is like kind of not applied for all parents. It's up to you. You can estimate, you can guess, but usually like this is related to wording and language. What is it here? Example 3, identify sources of possible bias. The use of non-neutral language in the wording of the question. So here's the answer of the question, right? So this is introduce possible measurement bias into a survey. This is kind of the right here they say a non-neutral language in the wording of the question. This is kind of the component of like measuring bias, right? Definitions. Okay, so how do I make it right here? Okay. So about SRS is we call simple random sampling. Simple random sampling, you can define as the following. You can define as we draw the subjects, which is you got like for example, I have a bag of marbles, different color. You draw out the red color. What is the probability that the red going to be, stuff like that. We call simple random sampling. That is one of the example. With that replacement, right? Or replacement, with that replacement, stuff like that, we call simple random sampling. The second is a random sample is one in which every member of the population is equally likely to be chosen from the sample. It means even though all the marble is different color, but they still have the same chance of drawing. So that's what it means. All of the member, all of the things um, in the random sampling, they having the same chance, equally likely outcomes. A true random sample is difficult to achieve. Okay, this is one of the facts that I think like a true random sample is hard um, to get it. Statisticians have developed methods for producing random sample that can be used to estimate characteristic of populations. Actually, this one is like it's just like belief of star people. They develop a methods that can produce the random samples. Actually, this is one of the examples saying we having some software. They just like run the simple random sampling from the software. I don't remember the software names, but like some of them using the software to do simple random sampling. I think one of that will be you have learned chapter 4 about correlation coefficients. I gave you a website to practicing finding art. So that's kind of might be considered as a simple random sampling. Like you just click and they change the sample, right? They change the position of the dots moving around. That's kind of the simple random sampling using software. Okay, I think I've finished 7.1. If you have any question, please let me know right away. Email me. Let me know that you don't understand that section on what page, that concept. Please let me know.